Okay, you guys do that later. Okay, let's discuss today's quiz. I mean yesterday's quiz.
I wanted to.
Did I hear a sound? Did it go off?
Because I didn't get any disaster. Oh, fun.
No.
Thank you.
So this is the graph problem.
But I did F.
Where's the chart?
I did 50 plus F.
So usually what happens, they're just going to give you a different graph. Usually there's a semicircle in it somewhere. So you got to
I got like 70
and then
times, so.
and when they label points, usually that's for a reason. Probably going to use it somewhere in the problem. This is the graph of f. And then of course they always tell you g of x is the integral from 1 to x of f of t dt. So you know somewhere in this problem you're going to use the fundamental theorem of calculus part 1. You're going to take the derivative of that. So part A, compute g of 2 and g of negative 2. Okay, this is, we need to get these 2 points. Some of you are forgetting the minus sign and things like that. So if you plug in 2 for x, you get the integral from 1 to 2 of f of t dt. So if this is the graph of f, the integral from 1 to 2 is the area between the graph and the x-axis right there. But you can see that it's below, so you gotta like make it negative. So it's negative, and that's just a triangle. So you go 1/2 base times height, and you can just leave your answer like that. How do I know the height right here is 1/2?
Slope.
Yeah, because that's 1 here, right? This is 1, and since that's a line halfway in between, then it's going to be a half, right? And then if I plug in negative 2, you get the integral from 1 to negative 2 of f of t dt. But then we got the smaller number on the top, so when you switch the limits, you got to negate the value. Don't lose that minus sign now. And the integral from negative 2 to 1 is simply this area here. This one and this one, but this one is below, so that one's going to come negative. So just be very careful. So this is a triangle, so 1/2 base times height. And this one comes negative, minus, that's half a circle, 1/2 pi times r squared. And just leave it. And that's 2 easy points right there. B. Let's squeeze it in here. B. Compute for each of g prime of negative 3 and g double prime negative 3, find the value or state that it does not exist. So first we've got to find the derivative, g prime of x. And you guys are used to this already. Just make sure the lower limit is a constant. Take the x and plug it in. You get f of x times 1. And then, of course, if you take the second derivative, then that's just f prime of x. So if you want to compute g prime of what number was it? Negative 3? That's simply f of negative 3, which is, well, if this is the graph of f, f of negative 3 means when the x coordinate is negative 3, your eye should go right there. What is the y coordinate? And since it's a straight line, it has to be halfway in between, so it's 2. And then, if I want to compute g double prime of negative 3, that's going to be f prime of negative 3. Well, if this is the graph of f, f prime of negative 3 means at this point, what is the slope? Derivative means slope. So you can just go, I mean, some of you can just eyeball it, but you can just go y minus y over x minus x, and you can leave your answer like that. Or you can simplify it to 1 if you want, because you can see that the slope of this line is 1, yeah? Rise over 1. Okay, so that should be 4 points we have in the bag, hopefully. C, find the x coordinate. Now some of you are not answering the question now. Find the x coordinates at each point where the graph of g has a horizontal tangent. That means g prime is 0 then, right? But g prime is equal to f. So this graph here, f prime, is also equal to g prime. So where on this graph is g prime or f equal to 0? Wouldn't that be here and here? So the answers would be x equal negative 1 and 1, because some of you didn't like explicitly state it. You want it to be on your paper. Answer all the questions. number line. Anytime it says max bin point of inflection, you're gonna make number lines. So G prime, which is equal to F, make a number line. Make a number line for that thing. Where does that graph touch the x-axis? At negative 1 and 1. The graph is above, it's below, and then it stays below. What does this mean? G is increasing, decreasing, and decreasing. So we can see, and that's another thing, you know, when you guys look at the scoring guidelines, that's not like the Bible, you know. That's just what they want to see. You notice that they don't ever use number lines on that. We do number lines. AP people, they don't like to do number lines for some reason, but number lines work in all kinds of situations. That's why we do it. Okay, so like right here, you can clearly see that there's a maximum right there. So there's a maximum at x equal negative 1 because G prime, which is equal to F, changes from positive to negative. And you guys are doing a good job with that, I noticed, so that's good. Remember, when there's two different functions, you gotta give both of them now. And then what about at 1 here? Is that a max bin or neither? Yeah, you can see if it's going downhill and downhill, it's neither. So there's neither at x equal 1 because G prime, which is equal to F, does not change signs. Just those simple phrases will get you all the points. And then D, points of inflection, that's a typical one. So we need to make a number line for the second derivative of G, which is equal to the first derivative of F. So that means we need to make a number line for the slope of this graph. So the first thing you look for, where is the slope 0? Boom, right there. So that's at 0. And the next thing you look for is where is the slope not exist? Where are there sharp points? Well, there's a sharp point here, there's a sharp point there, and there's a sharp point there. So on your number line, you should also have negative 2, negative 1, and 1. Negative 2, what did I just say? Negative 1 and 1. So remember, if the graph is going uphill, it has a positive slope. If the graph is going downhill, it has a negative slope. Downhill, it has a negative slope. Wait, something's wrong
You
here.
put your plus sign in for the first one.
Oh, no wonder. This is plus, now minus. Now minus again, uphill positive slope, downhill negative slope. So what does this mean? Well, to us, the AP people, they never do this, but we do this. We know that it's G is going to be concave up here, concave down, concave down, concave away. So where do you have points of inflection? Where does it change concavity? So we have points of inflection at x equal negative 2, 0, and 1, because G double prime, which is equal to F prime, changes sign. So the AP people, when they grade the AP exams, they're not going to look at your number lines anyway. They're just looking at these phrases, but we use them to help us get the answer. Because like I said, it doesn't work and just work in this problem. It works so for other types of problems too, where the information is given in different ways. So no matter what kind of problem you're doing, if you just resort to number lines, that will answer all the questions. And then you just have to put in the correct phrases to get the points. Hey, any questions on that?
So we don't need the candidate test table for C?
No, only if they ask for absolute max or min.
Oh, okay.
So if they were to ask you, what is the maximum value of G, or what is the minimum value of G, then you would do a candidate's test. But they didn't ask it in this problem. Like if they just ask you, is there a relative max or a minimum here, then you just have to say either yes, because F prime changes from positive to negative or things like that. Candidate's test is only to find absolute maximums and minimums. Don't worry, we're gonna have to take a quiz on that. We've gotta get good at that, that's fine. Now, tonight's homework this is the last of all the categories. Implicit differentiation and miscellaneous problems. So miscellaneous problems, usually 1 out of the 6 free response questions is gonna be something that you don't know. Like they might give you a chart. Look at seen before. So you gotta be ready for those. See, look, chart. Looks like you could make a number line for that too. And then here's a graph. So miscellaneous can be anything. Okay, but we need to review implicit differentiation. When do you use implicit differentiation? When it's difficult or impossible to solve for y, because you guys are used to functions given as y equals, but it's not always going to be that. So let's look at 2015, number 6. See right here, like that? It's impossible or difficult to solve for y. And then in this problem, they're actually telling you what the derivative is. You just have to show the work. And you know why they give you the answer for the derivative?
Solve for double.
Yeah, because you're gonna have to like compute the second derivative. So if you mess this up, then there's no way you can get part C. So that's why they actually give you the first derivative. You just have to fill in the work. In fact, why don't we do that problem then? Okay, so number 6, y cubed minus xy equal 2. You can't solve for y, so you do implicit differentiation. So remember, when you do implicit differentiation, the derivative of x is 1. The derivative of y is y prime, or dy dx. So right here, box cubed, 3 box squared times the derivative of box, which is either you write y prime or dy dx. They don't care which one it is. But if you just put 3y squared, you're out of the problem already. Minus, this is a product, you gotta use the product rule. And don't forget to distribute that minus sign after. So think of that as a product. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. And again, dy dx or y prime, they don't care. Equals, and of course the derivative of any number is 0. So you write that on your paper, you get 1 point. The other point is, can you do the algebra to solve for dy dx? So just be very careful. Well, you got the answer, right? So if it doesn't come out to the answer, then go back and check it, right? Don't forget to distribute this minus sign. So if you want to solve for dy dx, keep all the dy dx terms on one side. And then this thing you throw on the other side. I'm going to factor it out already just to save a step. So you can see that dy dx is equal to y over 3y squared minus x. Does that match the answer?
Yeah.
Yeah. So you can kind of tell. Anyway, that's why they give you the answer, because you're going to, like I said, if you botch it up, you're going to be out of points. Okay, now B, I'm not going to do it for you, but what would you do? It says find the coordinates of all the points on the curve where the tangent line is vertical. Now, I don't know what this graph looks like. It might look something like this. I don't know. So they want you to find the points where the tangent line is vertical. I don't know how many points there are. Maybe there's only 1, maybe there's 3, I don't know.
Set the denominator.
Exactly, because what's the derivative, what is the slope of a vertical line? Undefined. So if this is the derivative, if you want this to be undefined, the denominator has to equal 0. What if they said we want a horizontal tangent line? Then you set the numerator equal to 0. So just by setting the denominator equal to 0, just by showing this on your paper, you're going to get 1 point for that. But then now, you have to find all the points that are on this curve that has this property. So what do you have to do?
Solve for one of those.
So solve for one of the variables. It's easier to solve for x, it looks like, right? X equals 3y squared. Take that and plug it in here, and then just use algebra to solve it. You guys do that. That looks like at least a 3-point problem. It could be 4, I'm not sure. And then C, compute the second derivative at the point on the curve where x equals -1 and y is 1. So that's a pretty basic thing. So that one might be only 2 or 3 points. Find the second derivative and plug in those numbers. That's all you have to do. So here is the first derivative. How do I find the second derivative? Now you can either write this, most students don't like writing this, or you can write y double prime. It means the same thing, yeah? So second derivative, this is a quotient, you need to use the quotient rule. Okay, so who's gonna do this? This is part of our drill today. Total. Use the quotient rule on that.
3y squared minus x times y prime minus y 6y times y prime minus
Minus.
oh wait,
It's perfect so far.
1
Okay.
and then over that square divided.
Yep. There you go. I'm not sure. I'm guessing you get 1 point for that. Maybe 2. I don't know. And then all you have to do to get the last point, simply plug in -1 for x and 1 for y. And you don't have to simplify it now. You could just do this. 3 times, what is that? 1 for y. 1 squared minus negative. You don't have to, and then y prime. What is y prime?
That.
Yeah, so you gotta plug those numbers into this to plug it in there. So it's just a matter of plugging in numbers. You guys are gonna do that, yeah? I'm not gonna do the whole problem for you. Somebody had a question?
Why isn't it x prime?
X prime is 1. So whenever you do implicit differentiation, the derivative of x is 1, but the derivative of y is dy dx, or y prime. So x prime is 1. Yeah. Question?
Can we just plug it into there? Like, can we just write off the numbers?
No, you can just plug it in.
Oh, okay.
Yeah, you don't have to simplify anything.
Oh.
In fact, I would recommend you guys don't simplify it. Okay, and then of course, in implicit differentiation, this is where you probably will see the second derivative test, which some of you forgot. So here, I'll make up a problem. So, maybe somewhere in the problem, they'll give you dy dx is equal to,
0.
y squared minus 3x or something like that. And then they will ask you at the point, okay, let me come up with something. 3, 4, 5, 6, comma 12, at the point 6, 12. Now, is the point 6, 12 a relative max, relative min, or neither? And then explain your answer. This is where the second derivative test is going to come in. Now, what was the second derivative test?
Maybe
It tells you whether you have a relative max or min. So the first condition is the first derivative has to equal 0. You have to have a horizontal tangent. The second condition is you look at the concavity. So you have to look at the second derivative. Here, let's do this a little bit. If the second derivative is positive, that means the graph is concave up, which means you what? That's a relative minimum. If the second derivative is negative, that means the graph is concave down, and you have a relative maximum. So again, I don't really memorize it, just draw the pictures. It's easier. Okay, so is the first derivative 0? So if you're going to use the second derivative test, you got to show all your work that leads up to it. So the first derivative is 12 squared. No,
Switch the numbers.
I switched the numbers. Let's change it back to 12. 6 squared minus 3 times 12, that's equal to 0. So we know the first derivative is equal to 0. We got the first condition. Now we gotta look at the second derivative. Okay, if this is the first derivative, what do I have to do to get the second derivative? Implicit differentiation. Tom, do implicit differentiation on this.
Qy times y prime minus 6.
Yep. And then plug in whatever numbers into this, and what do you get? 2 times y, which is 6, y prime, which is 0, minus 3, what does that come out to? Negative 3, which is negative, which means the graph is concave down, so this is what you have, this situation right here. So then you can write, it's a relative maximum And what's the reason? Because
Of the second.
the second derivative test of because this is a theorem, you refer to theorems and definitions. Because of the second derivative test, and then you're happy about that, put an exclamation mark.
Wait, what if we just state the conditions? Like,
Yeah, but then you have to show that this particular problem meets those conditions though.
no, yeah, you just do all that, and then in the writing portion, you say, like, say you forget what the thing is called.
Oh, yeah. So you could say, okay, so if you forgot the name of it, just say, well, since the slope is 0 and the graph is concave down there, it must be a relative maximum. Yeah, you can do that too. Okay, so I'm looking at 2016. So the next thing is, you better know, look, they're testing to see if you know the chain rule, the quotient rule, and the fundamental theorem of calculus part 2. Okay, so so we're just gonna do drills because these miscellaneous problems could be anything, that's why. Okay, who's next in line? Tapper. What is the limit as h approaches 0 of f of g of x plus h minus f of g of x all over h? Okay, when you see limit h approaches 0, what is this telling you?
Derivative.
This is the definition of the derivative. What function are you taking the derivative of? That, right there. So then, you need to take the derivative of that, so Pepper. I'll give you a hint, this is the chain rule. You have to have it memorized, otherwise you can't answer that question, that A problem. Mhm. Yep, there you go. That's the chain rule. Just memorize the darn thing. And then of course you have to plug in numbers and then you look at the chart to compute the numbers, yeah? So but just by writing that down on your paper, you're gonna get 1 point. And then hopefully we can look it up on the chart. Alright, who's next in line here? Lee. Connor Lee. Integral from a to b of f double prime of x dx. What is that equal to? Okay, so just give me the final result.
F prime of x plus c.
No.
F prime of F prime b minus F prime b.
Okay, there you go. This is the fundamental theorem of calculus part 2. How do you compute any integral? You take the antiderivative of this, which is f prime, plug in the top number, bottom number, and subtract. Fundamental theorem of calculus part 2. So that's what you're going to do on part C. Let me scroll down to see what else we need drills on. Oh, and then I spent this entire morning making solutions for your because tomorrow we have a multiple choice, so I just made solutions for everything. So we're gonna be taking 4 multiple choice tests, so I'll just make solutions for everything.
Wait, we have a test tomorrow?
Oh no, that's just your homework. It's the multiple choice
okay,
portion.
okay.
Okay, so 4D. Let me see this whole thing. Plus, this will make your homework go faster. Okay, so in problem 4D, you have to compute the derivative of this. So g of x is equal to f of x quantity cubed. So how would you take the derivative of this? Who's next in line here? Suzuki, how do you take the derivative of this?
3 f of x squared times f prime.
Exactly. This is the chain rule. How do you take the derivative of box cubed? 3 box squared times the derivative of box. And then they want you to plug in numbers, so then you plug in the numbers in. This one doesn't have a chart, so you're going to have to figure out the numbers in other ways. Okay, and then let's do 4A. Let's do some drills here. When you see this function, what are you thinking?
25 minus x
I know, this is like a base graph,
squared. Oh, this is a semicircle.
semicircle. Although I don't know if it's gonna come into play in this problem, but ding. Okay, so first thing you gotta do is you gotta be able to take the derivative of this correctly, because otherwise you're gonna lose all kinds of points. Justin Lee, derivative of this.
Half times 20 75 minus x to the negative half. Oh, times -2.
Yep, that is perfect, right? So if you need to change this to 25 minus x squared to the 1/2 power. So how do you take the derivative of box to the 1/2? 1/2 box to the negative half, don't forget the negative half now, a lot of people do that, times the derivative of box, that's the chain rule. Okay, you write the equation of the tangent line, Okay, and then they give you this problem. Let's just go over it. So they give you a piecewise function, see, miscellaneous, could be anything. F of x when -5 to -3. And then it's equal to x plus 7. -3 is less than x is less than or equal to 5. Okay, here's a piecewise function. Is this function continuous at x equal 3? Is g continuous at x equal 3? How do you tell? Moroka. How do you tell if a function is continuous, if you have a piecewise function? So the two pieces meet at -3, so,
You have to plug in 3 and see if they're the same number.
okay, so do it.
Uh,
So f of -3 is,
Oh wait, isn't it negative 3 then?
hmm?
You said x equals 3.
Oh, okay, -3. F of -3 is, okay, and then, what about this?
4.
-3 plus 7 is 4. Hey, they're the same number. So the answer is yes, it's continuous. Because if they're the same number, that means they actually meet and touch at the same point. But now, to get the other point, you gotta say why. Do you remember? Kinderleiter, what do I need to write? Because, remember the definition of a function being continuous? Okay, I'll start you off. The limit,
X equals which is 3.
oh, your voice changed. Of f of x. Oh, no, sorry, g of x. This is g of x. Is equal to g of, that's right. So, and of course, you could say, so this is the definition, and you could say something like, 4 equals 4, something like that, to make sure you know what you're talking about, right? Now, they don't ask this, but is this function differentiable at x equal -3? I'm gonna ask that. Is g differentiable
No.
at x equal -3?
No. Oh, sorry.
So how do you tell if a function is differentiable?
So
How do you know it's gonna be smooth? Because we already know it's continuous.
same right slope.
The left-hand slope and the right-hand slope gotta be equal. So the only way a graph can be smooth, the left-hand slope and the right-hand slope gotta be the same. So we have to check the left-hand and the right-hand slope. So, okay, so do we know the derivative of f of x? It's this. So I'm gonna write, in fact, we can cancel the 2's already, so you get -x times 25 minus x squared to the -1/2. When -5 is less than x is less than or equal to -3. And then, what's the derivative of x plus 7?
1.
It's 1 on this other interval here, right?
Mm-hmm.
Okay, so we already know the right-hand slope is 1. How do I figure out the left-hand slope?
Plug in
You
number.
gotta plug in -3. So what happens when I plug in -3 into this?
Different
You
than
get
one.
-3 25 minus negative 3 squared, which is 9 to the negative half. That comes out to 3 times 16 to the negative half, which is 1/4. So that comes out to 3/4. Is 3/4 the same as 1? No, so this function is not differentiable. There's a sharp point there. So what do you have to say? No, because the left hand slope is not equal to the right hand slope at x equal negative 3. And then you can say something like, well, 1 is not equal to 3/4 or something like that. Suzuki.
You know the does not equal sign? Does the slash go that way or is
It
it?
doesn't matter. I mean, most times it's like this, but then if you want to be different, I guess you could do that. And then D, you just got to compute that integral, so that's easy. How do you compute that integral?
Which
I
one?
don't know if you can see it.
Why not
2012 D.
theorem?
I know, but what technique? It's either on the list or you got to do U substitution, right? Maybe some of you can't see it. It's the integral from 0 to something, 5, x times the square root of 25 minus x squared dx.
You.
Is that on the list?
No.
No, so the only way you can do it is use substitution, right? What would you make u, okay, who's next in line here? What would I make u equal to? Highland.
U equals 25 minus x.
Okay, you guys can take it from there, right? Okay, well, we'll see. So hopefully this will make your homework easier. Yeah, how much time? We got 2 minutes. We can still do drills here.
Oh wait, can you go over one of the questions in the homework?
Oh, last night's homework? Okay, what was it?
I think it was 2015 4D.
Okay, tell me what it, oh, was that the y equal mx plus b?
Find that in B.
Okay, that problem right there.
Don't worry about it.
Yeah, don't,
Oh, okay.
I mean, I would like to go over it, but I guess I forgot, we'll do it next time, tomorrow. But see, if you miss that problem, that's the kind where less than 1% of the students in the nation get that, so. If you miss that, which is probably almost everybody here, don't worry about it, that's not gonna affect anything. They like to put that kind of problem once in a while, I'm not sure why, because it really doesn't differentiate, because almost everybody in the nation gets it wrong. Okay. Okay, whose turn is it?